All right, so we're going to continue our lesson answering some questions about identifying or even ranking molecules in order of the strongest to weakest intermolecular force or highest to lowest melting or boiling point, okay? So this is going to apply the things that you've learned in the previous two lessons. So in this first example, after we finished all this other, it says list all types of intermolecular forces that would occur in each of the following. So we have to look at the formula and we have to determine what type of intermolecular forces are present. So in the first example, let me just back up. In every example, there's one type of intermolecular force that you'll always see, no matter what, okay? And that's going to be the weakest, which is dispersion forces. So for each of these, we're going to do an H for hydrogen bonding, DD for dispersion, and DD is for dipole, and then a capital D for dispersion, okay? So in letter A, we're going to write dispersion because everything has dispersion. Let's see, do we have dipole? Do we have carbon, something other than just carbon and hydrogen? And do we have something that's not bound to just itself? Okay, and yes, we do. We have carbon bound to fluorine, so that will lend itself to dipole. Do we have hydrogen bonding? Do you have hydrogen bound to N, O, or F? No, so that's it. And out of these two, which is the strongest? Dipole. Okay, all right, letter B. Do we have dispersion? Yes, everything does. Do we have dipole? Yes, because carbon is not bound to hydrogen and it's not bound to itself. So we have dipole. For letter C, we have dispersion. Okay. Do we have dipole? Yes, we have oxygen with another oxygen. However, they're bound to a sulfur. So it's not sulfur bound to itself. So we have dipole. Do we have hydrogen bonding? No, it's not H2O. It's SO2. So this is sulfur dioxide. Okay, and then finally, we have, in letter D, we have bromine bound to fluorine. That's going to be dispersion. That's also going to be dipole because bromine isn't bound to another bromine and it's not fluorine with a fluorine. Is that hydrogen bonding? No, it's not hydrogen with fluorine. It's bromine and fluorine. Okay, so that's that example. Moving on. Number 2, this would be a really good test question. So it says, list the dominant, which is the strongest intermolecular force present for these pure substances, then rank these in strength from 1 being the strongest, 2 being the one in between, and 3 being the weakest. Okay? So the first one is HBr. So what type of intermolecular force do we have with HBr? You should pause this video and try to answer these without my help. So for HBr, we know we're going to have dispersion. Do we have dipole? Yes, we do have dipole. Do we have hydrogen bonding? No, hydrogen has to be bound to one of 3 things: nitrogen, oxygen, fluorine. So no. So the strongest is dipole, and that is the intermediate strength. Let's look at the next example. We have oxygen, diatomic oxygen. By the way, there's a lot of elements that exist in their natural form as diatomic molecules, 2 of them together. So this is bound to itself. That should be a dead giveaway that it's what? Dispersion. And dispersion is the weakest. So that's going to be a number 3. Okay. Next, we have CH3OH. This is actually methanol. So CH3OH. So we know we have dispersion. Do we have dipole? Well, we have C and H. That's not a dipole. But the O and the H is, okay, because that's O, not bound to itself. And then, let's see, do we have hydrogen bonding? So we do, and not because of this hydrogen, but because of this one right here, because it is shown as OH, that is hydrogen bonding. So hydrogen bonding is the strongest strength. Okay? All right, moving on. Number 3, we have to circle the ones that can form a hydrogen bond, okay, in its pure form. So can these hydrogen bond? Explain why. If it doesn't, explain why it can't. So C2H6, does this hydrogen bond? No, it does not, because there's no hydrogen bound to oxygen, nitrogen, or fluorine. That is the reason why. Can this hydrogen bond? Well, not this part, because that's carbon and hydrogen. But do we have hydrogen bound to N, O, or F? Yes, we do, right there. So this can hydrogen bond. What about potassium chloride? Can that hydrogen bond? No, because you don't have hydrogen bound to N, O, or F. Can this hydrogen bond? Well, not that part, not that part, not that part. But guess what? This OH, this can, and it has to say OH, not H and then an oxygen, okay? So that can. And so this one, hydrogen bonds. And then there's another example that's a little tricky. Let's look at this. So I see a hydrogen and I see an oxygen, but the order in which it's given tells me that no, this last formula cannot hydrogen bond. The oxygen has to have a hydrogen right after it for it to be a hydrogen bond. The way this is written out, you've got the oxygen bound to 2 different carbons, okay, not to a hydrogen. So that does not hydrogen bond. Now that we've discussed this, I could put this on a test. Had we not seen this example before, I would not have done that to y'all. Okay, we needed to have that discussion first. All right, moving on to number 4. Number 4 asks us to rank each of these 3 from weakest intermolecular force to strongest and justify our answers. So first we're starting with iodine. Iodine is bound to itself. So that should be a dead giveaway that it is dispersion forces, which is the weakest. Okay, then we have H2S. Well, I have 2 hydrogens, but they're not just connected to each other. They're both connected to a sulfur. That's not N, O, or F, so it's not hydrogen bonding, it's dipole-dipole. And then the fact that this is water should just be a dead giveaway. However, you have H2O is really like HOH. So it is OH in disguise, and that is clearly hydrogen bonding, which is the strongest. Okay? Number 5, this would be a really good question on a test, but instead of just asking you to pick which of these 4 have the highest melting point, I want us to rank these. Okay? So we're going to rank these as which has the highest melting point to the lowest. So highest melting point should involve hydrogen bonding. Which one of these looks like it has hydrogen bonding? This one right here. So that is going to be our first one, and that is because of the hydrogen bonding. All right, next. Do we have any others that hydrogen bond? Nope, but I see a dipole-dipole. So is it in here? Nope, that's carbon and hydrogen. Carbon and hydrogen. This one, letter C, is the dipole-dipole. That's going to be our second highest melting point. Well, then we have 2 examples here that are both carbon-hydrogen. We can still rank these because the one with the higher molecular weight, the one with the more C's and H's, that one is going to actually be the next highest. This is actually a liquid, and methane, that one is actually a gas. Okay? And both of these involve dispersion forces. Next, number 6 says circle all the compounds that would be expected to form IMFs that are hydrogen bonds. So not that one. That one's tricky, but there's no OH. That one is really tricky. It doesn't exactly form hydrogen bonds, even though it looks like it should. So don't circle that one. Letter F, hydrogen bonds. And then letter C, because that's H attached to a fluorine. Okay? All right, moving right along. Skipping over number 7 for a second, I want to make sure we have time in the video to go over number 8. There will be test questions with this information on there. So, for letter A, actually for this whole thing, we have to determine what's the dominant IMF, and whichever one has the strongest IMF is going to lend itself to the higher boiling point. So that's what we're going to do right now. So HCl, I have hydrogen, not attached to NO or F, so this is just dipole-dipole. And then I have I2, iodine bound to itself. That's going to be dispersion. Which one had the stronger intermolecular force? HCl. That's the one with the highest boiling point. Next we have CH3F. Even though this is HF, this is not HF alone, and it's actually the fluorine's bound to the carbon, so that's not going to work. Okay, so it is just dispersion. Whereas this one, we do have hydrogen bonding that takes place. So CH3OH is definitely the one with a higher boiling point. Letter C. This one should be a dead giveaway. You have water and anything else. Well, water, hydrogen bonds, okay? But this does not. This is just dipole-dipole because you don't have hydrogen bound to NO or F. So the higher boiling point is water. Letter D. You have SiO2 and then SO2. Both of those are dipole-dipole forces, okay? However, one of these is a special case that does the network solid. Which one is it? It's silicon dioxide. So it's our first one. And remember, silicon dioxide, it forms sand, glass. That's a very unique case. Okay? Letter E. You have just metallic iron. Okay? Metallic iron, it can't bond to anything except for other irons. So that's a dispersion force. Krypton, same scenario, just a dispersion force. Which one has the higher boiling point? Well, for this one, I want you to think about the first table that you were writing notes on, and that, metals. Have you ever, think about your common sense. Have you ever been able to boil a metal? No. Krypton's a noble gas. It's already a gas. How can you boil something that's already a gas? It's already boiled, right? So iron is the one with a higher boiling point because even though you can boil it, it has to be thousands of degrees, okay? So moving on. This next one, you have hydrogen bonding and then copper oxide. Well, you've got something that's bound to a different element, and it's not carbon with hydrogen, so this is dipole-dipole. It's actually an ionic compound, but the higher boiling point, you would think, is CH3OH. However, I told you guys there are cases where there's a weaker intermolecular force, but it has a higher boiling point. Why? Because ionic compounds, they always win. They have that special lattice structure, okay? Have you ever boiled salt? No, you can't. You can dissolve it and boil the water away and you get the salt again, but you can't actually boil salt. So that one is copper oxide. Would I ask this on a test? No, don't worry about that. Be able to get through maybe the first 4, but don't worry about letter F. Okay, moving on. Letter G, actually, you should be able to do that one as well. Okay, so letter G, NH3. What's our dominant force? Hydrogen bonding. And then we have dispersion. Which one has the higher boiling point? NH3. Okay, and that's about all we have time for.